Assalamualaikum warahmatullahi wabarakatuh. Very good afternoon. I'm glad you're here. We're glad also for Professor Mine already here. This is the third session of the FGS guest lecture series. The third session is about the application, also a little bit about some of the introduction of the functional graded polymeric material that will apply it in a adhesive joint. Yeah. So we are going to focus in this topic in this session. And before we start, I think I will remind you to scan the QR code because to get certified, and also some of your lecture need to have your presentation. So fill up the form of the presentation from your lecture, and also you can see in front of your table already a brochure. Is about the lab of the MBP, ya, Mekanika Benda Padat, which is, yes, we open the door, we open the student to join with us, to research with us. You can look at on the topic inside the lab. There's a lot of topic, mostly about the structure, about some of them about the adhesive also, about the design, and some of you know that we also focus on the finite element method, using the finite element method to simulate and analyze the structure. I also need to mention you that in MBP also have a topic of the composite also, natural composite, and what others? Tribology, as Mr. Yusuf Kailani. We also have the tribologies, and I think the other one is you can look at on the brochure. Oh yeah, I need to read about I think some of you not yet know about the Professor Mine, so I will read about the simple one of the historical of the Professor Mine. Is it correct? I call you Professor Mine. Mine, sorry about that. Professor Mine, no. Okay. Professor Mine was born in Eskişehir, yes, Turkey in 1983. You know the 1983, and she graduated mechanical engineering at 2005 from the chemical, isn't it? Yeah. Okay, I introduce myself. Okay. Yeah. Hello, everyone. Thank you. Firstly, I thank you for attending this class. This class is related of the applications of the functional polymeric material and in adhesive bonding joint. I want to introduce myself. I finished my master degree from Polytechnica Silesia, so I learned from them some functional graded material technique. Russia people is very good in the material engineering, I think that. And also I finished my PhD in Yildiz Technical University. I'm from Istanbul. Istanbul is not capital city, but the second, the bigger city in Turkey. And also my
another postdoctoral degree from the University of Kentucky, and I want to help you some specific problem, especially modeling of the advanced science material. In our previous lecture, it was related of the functional graded polymeric materials, but its level is undergraduate students. Uh, and then it's a general information. Please, I got that the understanding is material like a commercial material, like a engineering material. No, FGM is a specific advanced material for science investigating. Okay, and then um, adhesively bonding joint technique is also hard for application and especially for theoretical and numerical modeling because adhesive is not like behavior uh, material like autotropic, linear isotropic is different. So it's hard to modeling. And I want to some advice. I want to show some specific study from my experimental and numerical case study. And then I will share my email addresses. If you can any support, especially PhD students, any support, I want to help for you because I studied nearly 7 years in that topic. I need to share someone. Okay, thank you for coming, and I want to start. Firstly, of course, we need a purpose, and of course, we need a motivation. And your specific study has to be original contribution. And firstly, we describe all the functional graded polymeric material, and we discuss on the two specific geometry. First geometry is single lap joint. It's a beam, and we used in the beam theory, Timoshenko, Bernoulli, beam theory. And then the another is a plate. We used shear deformation plate theory. And we used also theoretically sandwich structure. And what about of the loading? In the loading type is tensile and distributed load, and it's we discuss case of the buckling analysis in sandwich structure, and we discuss elastic stress analysis in the lap joints. Okay, and also adhesive is not a simple material. So sometimes it's a inclusion in adhesive there, so it needs to be modeling. Inclusion, I mean there's some poor, some unwanted materials, some cheap in the adhesive, so it needs to be modeling in the nano and microstructure. Yeah, because dimensions is changing, everything is changing. Every theoretical view is changing. And I will show a backlink behavior. It's glued plate panel with orthotropic inclusion. And I will show you a stress behavior and a single lab containing also orthotropic inclusion. I mean that adhesive is not homogeneous, it's a heterogeneous properties. Is it okay? Yes. What about our motivation? The use of the adhesively bonding joints for polymeric materials that are increasing of the many industrial areas, especially for this science. They are superior mechanical, thermal, electrical, and also magnetical properties. And the adhesive connection is consisting of the functional graded polymeric material, not metallic. Attention that functional graded polymeric materials, they use of the layered joints in the aircraft, shuttle bodies, and joint in car and ship frame, and the other surface of magnetic circuits, electromechanical sensors, and these area. So it's a need. There is a need to model the stress and buckling and delamination. Delamination formation in the adhesive connections as made of the FGPM as realistically as possible as develop, and we try to get new solution. I have shared some details about our material. Our material was based in the epoxy resin is a matrix, and graphite is a by adding of the graphite by using of the different percentage. Yeah, I talk about in the morning, and I want to shortly brief in new students by using of the centrifugal casting method. And then, additionally, we take a considerations of the adhesive layer like a heterogen. What does it mean? Because heterogen layers is discussed in the literature, and in problem, change in the elastic modulus in the adhesive depends on the stress in the intensity. So these are studies examining of the is the connection stress. So it's important of the when subjected of the tensile or shear loading, it's important to take a considerations of the heterogeneous adhesive behavior. What about our FGPM plates? We use all the sandwich geometry, and we connection creating by the adhering of the plates, and we subjected in plane shear loading. It's a some factors, effective factors is loading. Firstly, in plane shear force, the secondly normal compressive force, and then under-distributed. It was examined two different connections, in point supported and the linear supported. I will show you what does it mean linear supported. It's not like a basic beam. It's linear supported for a sandwich structure geometry. And we discussed in the lap shear, single lap shear, loading of the both tensile and both moment load. And we will discuss shear and field stress and von Mises stress. What about the air original contribution? We use orthotropic inclusion to get understand behavior of the heterogeneous adhesive layer. We use of the glass epoxy, glass epoxy and graphite epoxy and boron epoxy for inclusion in adhesive layer. We modeled it. And then we used ellipse geometry. Why? Because in the mathematical, you can accepting of asymptotes, and we accepting of the shape firstly ellipse, and we take a considerations of the dimension, and after that we get C over A is equations of the one, and I mean there's a circle. It's necessary for theoretical viewing and discussing is a specific ellipse geometry. Yes, we used PAM and PV. It's just on a name, just as a graphite, and you can see some types. You can see it's some image. It's not important. It's some image. I want to show you. It's a functional graded polymeric materials is manufactured like that. I want to say briefly. Firstly, we take a centrifugal casting machine and it's rounding around the axis, and we are pouring of the melted one layer and another second layer, so we can get a, for example, hollow part. So in the hollow part, it's material distributions is the highest on the outer surface. And so the all mechanical behaviors is changing by the thickness length. Is it okay? Yes. So we get some graphite, the adding of the epoxy resin, and we use image processing program for detecting of the how much graphite inside, detecting from the how size graphite in size, and what is the situation in the outer, what is the situation in the transmission gap. We can use image processing program and we can get some distribution data. Look at that, it's some distribution data. It's based on experimental. Okay, now it's based on theoretical. In generally, we have to define the model. It should be based theoretical. I give you two model how to say or Paul, sorry, I just don't know how to say. Okay, you can use all the many model for describing of the functional graded polymeric material. So how to say good, Lewis, many of the model. So you should use is the best one for your need. We choose the half-the-size model, and it's a basic, and you see it's a shape factor. Because of our graphite is flake, we shake a factor like that. If you can studying with another shape of the graphite, for example, shepherd, you can choose another shape factor. We studied in flake one. Anyway, we can get considerations of some mechanical properties. So if you use ANSYS asks you, please find the material. It's the basic options, of course. Take a linear, homogeneous, and linear elastic material, but it's so base. So we need some options, we need some crates by using all the ANSYS API program by using all the MATLAB. So it's necessary writing a code and this code is based experimental data, and then you made a model and you check both of them, because it's hard for calculating at the analytical method. So you can use, but your model should be true. I have some advice for modeling sandwich structure with adhesive bonding and adherent materials FGPM. Okay, look at that. We have three type of the loading conditions. Is first one is V. It's it's in plane shear force and normal force, and also it's distributed force. I want to image you a plate and with glue, and for supporting, can you see it's a 0.3 is fixed support? Try to remember strength of the material lecture. It's fixed support and it's shear support. So if we loading in the shear load, we can have corresponding diagonal and tensile diagonal. Okay, it's the cause of the buckling. It's a cause of the buckling. Can you get? Because in the inclined shear force acts support on the point 1, and these force create support reactions, and point 2 and point 3. So it's a compression diagonal. And then it's only support in 3 is fixed support, and inclined shear force is loading. These 1 and 4, it's become a tensile diagonal. So the plate, it should be buckling, okay? And then what about the linear support for us? In generally, in the architecture, we can use all this side of the support. Do you know pavilion? Pavilion is a structure. Both of them is used glass. Pavilion is all wall is glass and the top is glass. So we don't want to drill the glass. We don't want to use bolt. We use adhesive. And if the connection type is generally architecture linear connections, it means that sandwich structure is located in a hole with, you can see a sealant, with a sealant. It's a linear support. And another is support, another loading is it's pressure force. I mean that is M. And you can see finite elements. You can see some dimensions of the all sandwich plate and detail from the linear support panel. And we take a considerations of the silicon thickness. The model is like that. Sandwich panel is like that. Yes, it's important. Yeah, we used a solid element. We define of the element by using of the ANSYS. These analyses take a consideration in ANSYS, not abacus. Attention that. ANSYS, we can say it's solid element to model of the adhesive layer and adherent plate. And we choose a contact pair. What does it mean? It's an important point is choose a contact pair element between of the adhesive and adherent layer. So it must be located in the surface. Can you see? It's adhesive, solid, 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 of course. What about the interface? Interface is important because they are changing of the all stress behavior in there. So it was taken into account of the junta element. It should be replaced on the surface because it will be more deformed. And it was placed upper and lower adhesive. And this take a 8 node. And the element name is target. Target element is placed on the surface of adherent plates in contact with elements. So we have some restriction. We have some restriction in the meshing process, and plate take considerations of the plate thickness into the critical phases, of course, but you can take considerations of the whole part. So literature says that the ratios of the side lengths of the element on the solid element shouldn't be less 1/20. And the angle between of the element and gas shouldn't be less 70 degrees. And we use of the Gauss points. Junta and target element use of the in contact pair, the use of the Gauss points, they provide more realistic results than the nodes. So this element is located in the between of the layers, adhesive and adherent, and it's a contact pressure. Transmission occurs between all the Gauss points, not transmissions of the node. Generally, ANSYS use transmissions of the load by using of their own node, but we will form Gauss points. It's important. And we take a considerations of some interlocking and some restrictions of the dead points. What does it mean? It's penalty stiffness factor. Maybe I will discuss for PhD students in this specific contents. So connect penetration. You know penetration? Correct penetration, it must be taken a provide coverage in place. There's a contact model, and the penetration it should be small as small. So this is just only possible by increasing of the contact stiffness in the finite element analysis. So its default is 1. In ANSYS, its default menu is 1, but it's not to be a 1 because it's F key n, I mean the penalty stiffness factor. It should be determined by calculating of the theoretical view. So it should be repaid until acceptable penetration and optimum coverage is achieved. Is it okay? So it's a good literature, Maura, it's Italian, emphasizes that F key n value should be chosen carefully for achieve good performance. It's recommended 10 over 7 Newton over millimeter cube. And we say always bounded comments because we don't need a penetration. Look at that. It's a backlink behavior. Yes, it's a backlink behavior mode 1. Yeah, the plate is backlink mode 1, and the plate is backlink for mode 2. You can see 2 buckle. Yeah, image that just on this side. Yes, it looks like a beam. And what about of the mode 3? Yes, you can see mode 3, maximum and minimum von Mises. These are von Mises. Yeah, no, these are deflection points. So yes, I accept it's buckle plate. And we discuss some numerical results. We take a considerations of the first factor is additive sample graphite, PV and SPAM. And the other factor is its volume ration, 3, 6, 9, and 12. And we can discuss its critical backlink load. I mean mode 1. Mode 1 is critical backlink load. You can see of the for PAM, PV. For PAM, what does it mean? A PAM is both of adherents made of PAM and both of adherent made of PV. And the third one is one of PV and one of PAM. Both of them is functional graded polymeric material also. So we can take PV and PV sandwich panel is the best one because its critical backlink load is nearly 1054. The highest critical backlink load was determined of the PV and PV plate pair. And then these results show that because you're an engineer, you need the comments. You can of course some experimental, you can of course some numerical analysis, but the most important thing is comments. Good comment is important for us. This result is showed that PV graphite powder more compatible with the resin and is responded to better backlink condition. You can affect another for normal, at that time, normal compressive force. you take a considerations of the different loading conditions. Both of them is creating a backlink. The first one is this in plane normal compression, and you can see under distributed load. So their behavior is like that. Do you see? Yes, it's behavior like that. So it's a value experimental data. You can see in the figure, at that time is critical backlink load. At that time, it's linearly supported FGM under in plane of the shear loading. This in that figure is backlink hold in linearly supported. It's lower than point supported panel. Can you get that? Although the hole in the point supported panel, it reduce the panel resistance. So tensile and compression diagonal are formed the panel for the point supported, and this provided of the rigidity effect of the panel. And this effect enable the point supported panel. They have a small in-plane displacement and high critical backlink load. Okay. You can see another loading conditions. At that time, force is in normal compression force and linearly supported. I can share some value because it's important for viewing of its behavior. Under a normal compression force, the critical buckling load for 12% of the PEM and PEM sandwich panel, it's 5.78% higher than the critical buckling load of the panel without any graphite powder added. And graphite powder added, it means it's a pure adhesive, not adding any graphene. So adding of the graphene, yes, it's okay. It's changing of the mechanical property. It's a higher strength of the adhesive, and it's, what does it mean? It's mean higher strength of the all adhesive bonding joining parts. Yes, critical backlink load, it's linearly support if you loaded on the plane panel distributed load. We define of the Q distributed load, and you can affect of adding of the graphite powder in adhesive. Look at that, it's a good chart for get understanding of the critical backlink load. Please comment. In the first comment, it should be that panel with homogeneous distributions of the couple PV resin composite and PAM resin composite, PAM and PV resin composite, and FGPM panels is higher than critical value with the homogeneous distributed for all type and all volume ration. And it's adding of the percentage. In the sandwich panel, it's with the homogeneous distribution, all the critical backlink load is increased at 13%. Yes, it's 13% according to the volume fraction. All volume fractions is 12%. Yeah, it's a good critical backlink load. Yes, but about its validation. I shared it some experimental and some numerical result, but it's necessary validation. The verification and validations of the model was done by taking constellations of the classic sandwich theory. In the shear backlink coefficients, I mean that key tau, and critical shear backlink load, it's force critical. Sandwich panel under in plane shear loading. So we can check the literature, and Quanzi solved the buckling problem simply and fixed supported for rectangular isotropic sandwich panel subjected in-plane shear force. And the solution is offered by Quanzi was adapted the sandwich panel consisting of the FGPM, and you can see some equations. By applying of the Quanzi expression, equilibrium of the equations of the force is moment due to the in-plane shear loading. We can define of the deformant configuration. And we take a considerations of the flexure stiffness, and then it's important of the panel thickness, and it's important of the sandwich thickness, and we take a considerations of the all sandwich, and we take a considerations of the some factors. It may be for master students, some factors, you know, shear stiffness factors, and some buckling coefficient factors, like that. In Quanzi's advice, say us, please use the aspect ratio is alpha, and the shear stiffness of the adhesive, and you can calculating of the simple support panel for the sandwich structure. You can use of this. If you changing of the boundary conditions, I mean that if the boundary conditions is clamp sandwich panel, you can use of this empiric equation. So we take a considerations of the finite element result compared with the analytic one. The shear coefficient factor was calculating of the helping of the equations by given Quanzi, and elastic modulus calculating for half and psi, and we take a considerations of the analytic calculation for 30% PAM and 30% PV pairs, and we have just some differences. And in the finite element model, in this used was applies the glass sandwich panel, because we take a considerations of the geometry from the glass. Okay, so the glass was experimentally studied. They used of the linear support, they used of the point support in the architecture. So it's used of these from literature. And then its experimental study is calculating 6.9 millimeter in the point support sandwich panel and 45.6 millimeter in the linear support panel. And then in our model for glass, we calculating of the same critical buckling load. So we can say, yes, it's model and its construction and its using of the contact and target element and its restriction, its Gauss and stiffness factor. Yes, it's true. The model is true, and we check in the glass. The glass is based on experiment. Okay, we need to be verification like that. Okay. This that was is related of the plate, and that was is related of the its beam. Look at that. It's a single lap joint. It's a basic of the adhesively bonded joint, and we can subject it. It's a tensile load, and we can subject it in bending moment. So if the adherent was chosen functional graded polymeric materials, and you can see is these dimensions, it based off the literature, of course, and we take the effect of the graphite type and graphite volume ratio at that time, maximum fill, maximum shear, and maximum von Mises stress. Yeah, you can see. At that time, it's a plane, and you should choose a plane element. Its plane 182 element was chosen. It's just only 4-node element, but it's enough for to get a beam. So we used also again junta at target element at the interface area. This is a click point. This interface area, and we get some estimating. You can see its mean is displacement according to x direction, and you can see about the displacement y direction, and especially we take a considerations of the adhesive layer. In the ANSYS, you can check the solution for check the location, but sometimes we have some specific region, so we can create a path. Do you know that? We can create a path. We create a path by selecting the node. We define the path. So, and then we ask, please ask me what is the shear stress in that path? What is the von Mises stress? What is the deformation? Just only these specific paths. So the path was chosen in the midline in the adhesive. And overlap length is 16 millimeters. We can calculating or these shear stress, sorry, in Turkish, shear stress, and why it's that? Shear stress, healing stress, it's sigma y. You can understand sigma y, and shear stress, tau xy, and von Mises stress, sigma von Mises. Can you see? This axis is related of the percentage of the graphite, and the other is related of the stress. Yes, the stress. So considering of this stress, the highest value, that is the worst connection strength that are seen type of the connection without graphite powder added is equal to the 0%. However, it was observed that the stress value decreases as value of the graphite powder added increases. So these results is revelate that as graphite powders help improve the mechanical properties at the regime, they increase of the strength. And we need also verification. This is normalizing field stress. We generally use normalizing. What does it mean? It's free of the dimension. So we take a considerations of the sigma y over sigma original. It's normalizing field stress. In order to get verify of the finite element analysis and the data it's take from the adhesive layer, it's compared with the analytical literature. So for this purpose, mechanical properties of the resin, which is homogeneous rock material, were used in the analytical solution. And then when the finite element and analytical solution is the result is examined, it's seen that most critical points of the 2.3 ends of the overlap. In order to compare shear distribution occurring to adhesive layers and stress distributions of the sigma y and shear stress taken from the midline divided by uniformly distributed tensile load. And we use of the non-dimensional, and similarly x coordinate was non-dimensional because the overlap length is totally it's 16 millimeter, but we take a consideration X over L, okay? We did always normalize them because we don't want this value just related in this geometry. It should be free from the geometry. And the field stress distributions is obtained from the analytical solution compared of the field effect. You can see it's very, very close, and we take the numbers. Yes. So in this study is heterogeneous nature of the adhesive layer, take a consideration, and we take a realistic analysis. We take a realistic analysis, and in that figure, it's increasing of the graphite volume fraction is effective reducing of the shear stress on the adhesive. For indicator of the situation, it's more detailed. So 3 p.m. and 12 p.m. We can accepting and we can say, yes, our model is true and our model is verified by base of the analytical model. Okay. I need a break.
Thank you, Prof, for the detailed sharing about your research. You can see that the research is very detailed. The first thing we need to make sure that our model is accurate, and then we choose the element and also the contact. We need to put the contact because we need to have a accurate result, and then after that we need to verify and validate about the result. You can see all of the process of the research is very detailed, and I think it's inspired us, maybe inspired all of us to have maybe another research topic that correlate with this pattern, this topic. I think it's very good. Thank you very much for the sharing of the research.
Thank you. Okay. Now we take a considerations of the inclusion. Inclusion in the adhesive layer. I want to show also a specific case study. And this is backlink behavior in the orthotropic inclusion in adhesive bonding layer. So it's among all adhesive connections, the layers with the heterogen, and we have some okay. We have some examined of the effect of the change elastic modulus in adhesive layer, and it's Silva. It's a man from Portugal, and it's a headman of the composite structure. Very hard study in the for adhesive, and Carbas they have conducted intrinsic study has functional graded polymeric. So, in order to examine of the effect, okay, can you listen me? Yes, please relax and listen me. In order to examine of the effect of the heterogeneous layer, connection stability, and glue plate connection, subjected shear, and subjected shear loading and single lab joint. Take a considerations of the orthotropic material. You know, orthotropic material properties is changing the direction. You can see 3 elastic modulus, of course 3 shear modulus, and 3 position relation. We choose all the epoxy, graphite, and boron. glass epoxy, graphite epoxy, and boron epoxy. And we use of the Loctite, and this is connection. This connection is like a single lap joint, but it's a plate. We use of the first degree plate deformation theory, and we accepting inclusion in there. So in the adhesive layer, it has a elliptical inclusion geometry, and we take a considerations of the dimension C over A, likewise 0.125, 0.5, 1, 1.5, and 2. So the aim is C over A is equal to 0. We say that it's inclusion-free adhesive layer. So C over A is equal to 1. You know, it's just only circular geometry. And it's a shear loading. It's a shear loading. You can see is the mesh detail, is 3D mesh, and we can use again some surface contact elements. At that time, it's the inclusion. We can say it's adhesive solid. Yes, it's adherent of the adhesive solid and inclusion of the solid. But at that time, it's important thing is this surface, connecting surface. So the use of the connecting element in this surface and also in a whole adhesive. What about of the ration? We take a backlink analysis by subjecting of the shearing load, and you use of the critical backlink load. Yes, critical backlink load, it's C over A. I mean that the geometry is nearly to elliptical, go cylindrical. And the material effect, glass, graphite, and boron. Yeah, you can see its behavior. Its mechanical behavior, this is important for me. I'm a member of the mechanic division. You can see all the mechanical behavior in different mode. When you backlink analysis, you can get a first mode. It's give us critical backlink load, but it's not necessary. We can get another mode, mode 2, mode 3, mode 4, because we want to learn, and we need to learn the deflection of the other modes, not just only critical. So we get take a considerations of the 5 modes in that analysis. So it depends of the mode. And another part, at that time, the shape is circle. C over A is equal to 1. And they are using of the like that. It's elliptical, but another side. It's a horizontal side at that time. You can see at that time it's effect of the inclusion material. Inclusion is always a problem for us, and also inclusion material take a considerations is like that. Yes, you can see all the 5 modes, another geometry, and then what about all the geometry? You know that is from the geometry in take a considerations of the 5 modes. Critical backlink load behavior is like that. So when the inclusion is circular, C over A is equal to the 1, the density of the backlink load is quite different compared to the case where inclusion shape is elliptical. So, Professor, it's so easy for taking considerations of the circular. And firstly, we check the analytical form for the circular. So it's different. So we can use of the analytical solution for the ellipse. Can you see? Because it's different. The theory is okay for the circular, but we can say it's different shape. Its theory is not useful for the ellipse one. And also, theory didn't say ellipse properties, just only a circular properties, and we need a numerical analysis. And we can say the lamination. You know the lamination effect? The lamination damage is inclusion of the zone. I mean that if you are taking considerations of the composite parts by layer and layer, and you can see a problem between of the layers. It's mean a delamination. Delamination. It's a hole in there. So the aim here is to examine of the effect of the delamination. It may, of course, occur near the inclusion area, and we considering of the material damage problem, size of the delaminations effect, and then in discuss of the shape of the delamination effect, it's important. So we get a considerations of the delamination size. I mean that we define of the delamination area delamination, or delamination adhesive. Sorry, in Turkish, it's a yapışkan in Turkish. I didn't write in English, sorry. Area of delamination over area of adhesive, it's important. And also, it's the shape and directions of the delamination is chosen. So, look at that. At that time, again, we give all graphite by dimensions. Dimensions, critical backlink load is expressed as critical backlink over critical backlink with SR. And it's a critical backlink load of the delamination connected, and it's mean that critical backlink load for non-delamination. Is it okay? One of them has delamination, the other is non-delamination. And we take a consider delamination magnitude. It's 0.04 and over 0.08. So the result of the important result of the affect the shape of the delamination on the critical backlink load, you can see, and it's elliptical. It's an elliptical form. It's important, and is the verse delamination, of course, seen in circular. Can you see? Circular. 1. C over A is 1. So the verse delamination effect in circular delamination. What about of the material? It is small delamination with the area is equal to this behavior, and we can take in glass epoxy, for example, in glass epoxy inclusion, the lamination size is 8%, and the lamination shape is circular. The reductions of the in critical backlink load is more than 50%. And then these decreases is only 70.5 at C over A is 0.121. So in addition, the critical backlink load is decreasing nearly 45% for graphite and 40% for boron epoxy. What does it mean? It's a delamination effect so important. Take a backlink. It's a negative effect. You can use another specific mode. Okay. Thank you for listening. I think that's enough.
You want to break Q&A or another?
That's enough.
I don't know. Okay. So I just want to wrap up that uh, Professor already shared about the research. Start from the fundamental one, the buckling, and then goes to the another one, and then goes to the inclusion, and then it's very good example for us. Maybe you can inspire from it to make a topic of the research. I think it's very good. And all of the research is using only the numerical method, isn't it? Just using the finite element and then ANSYS and using the to do the research. I think it's quite good. Okay, next we have maybe 30 minutes, about 30 minutes or 1 hour or 45 minutes to Q&A. Maybe some of the there is a question, yeah, Q&A session. I'll give you about maybe first thing is the 3 question maybe. Is there any question from you? Okay, one, another one for beginning, but maybe one first. The first one, okay.
Uh, Firstly, I would like to introduce myself. My name is Iverson, and I would like to thank Professor Nine for the opportunity and for the lecture. Firstly, my question is very basic about functionality graded polymetric materials, about how is the variation and distribution of material properties controlled so it is consistent. Is it just by layering the materials? Thank you.
Thank you for its valuable questions. Do you know manufacture of functional graded polymeric material by using of the centrifugal casting? Okay, okay. I can show. We can get some sample from the centrifugal casting method, and please image a hollow part. And we take a hollow part by using of the light microscope and optical microscope, and we are checking, and the optical microscope is used image processing program. So what does it mean? Image processing program is calculating of its graphite particle, because they think about it's a dark area and it's a lighter. So the program say no, it's not located there. So it's foreign. So it's detect. So we can detect of the all particle size, and we can counting on them, and we get a percentage of the area according to the direction. We observed many times. I cannot show image according to thickness, and image processing is calculating of the concentrating, and we say yes, it's graphite panel is crowded in the other side, of course, and this is this value, and then we take a chart, and we use this chart in a theoretical model. We describe like that. Thank you.
So one more time, I would like to conclude your answer. So it was first mixed. So it was first the material are mixed together, and then the composition are checked by the image processing. Is it
Yes.
correct? Okay. Thank you
Yes.
for your answer, Professor.
Yeah,
Fede.
you're welcome.
This is quite difficult to look at on the material inside the material. We need to another tool, image processing already mentioned by Professor. I think that's the question. And then after that we can detect about the proportional of the inclusion or something like that lah. Right?
We use model, empirical model.
Use model. Okay. Oh yeah, before another question, I think help me to find your number, your handphone number. So we will give you some benefit over. Okay, another question? Yeah, the white one.
So first of all, thank you for your presentation.
Welcome.
So I'm Yassine from French. My question is about on this. So you talked about the way how to connect the two pieces with using content target, and is the way when we switch like the content and the target, is that affect the result of simulation?
Yes, yes, it's
Mm.
a click point of the
Mm.
FGM. It's my PhD. Yes, it's my PhD. We are using, it's a good questions because the modeling of the adhesive is the heart, and the question asked, please take a trick point in that. I'm sorry, it's another click point. We use of the, we writing of the data code from the MATLAB, and we using of the first deformation theory, first deformation shear theory. We writing that, and then we define of the contact and target element, but we touch them by using of the APDL, and we have some restriction. So it's not a basic analysis because we don't use node. We don't use node. We use Gauss point, Gauss theorem. It's necessary Gauss point. So ANSYS take a considerations of the ANSYS APDL and its use of your code, and its stress and force is transmitted by using of the Gauss point. It's a click point and it's in the code. But I can help you for by email for specifically. Good question. Thank you. Thank you for your interest.
You can contact with the professor. And I have one question. Why you using the Gauss? Is there any advantage of not using the node to find the contact, but using the Gauss? Is it problem with the node?
Because in the geometry, ANSYS is just only defined the nodes. So
Yeah.
it's not from adherent material and not from
Yeah.
adhesive material.
Yeah.
The ANSYS just only define one node. So it's except contact is directly.
Oh, I see.
Not glue, but
Oh,
glue
yes.
it's not directly steel and crop. It's
Yeah.
different because
Yeah.
we need penetration, we need
Yeah.
a
Okay.
possibility. So node is not useful for the describing of the
But
adhesive.
only one node, isn't it?
Yes.
Yes. Okay. Thank you. Thank you. Is there any question? Yeah. Very good.
Thank you for your interesting presentation. So I want to ask, how do you find the percentage value of fraction volume in graphite? why you don't try the value greater than 12%, maybe?
Okay, it's a good question. When only you choose all the factors when using all the experimental, you should first work in literature. So literature advise some restriction and you try and you obey to these restriction. So literature say that it's not working of like that, adding some graphite and take more strength. No, it's not like that. It's if you adding much more, it's a negative effect. So first you should the literature, and I take from literature this restriction.
Do you have any other question?
No, no, it's enough.
Yes,
Okay,
good
good.
question. Thank you. Thank you for your attention. I hope the attention of its scientific advanced material, and I hope it's a adhesive connection point, because it's a area for the take a good job in especially aerospace, and it's especially from the a good job, because it's different from the traditional method. I hope get your attention to my area. It's my pleasure. Thank you for your attending. I'm really pleasure with you. I'm also giving students is like you, and I think it's any differences between of you. Please, I have a little advice. Please hard study, and I want to say all your whole is dependent of these years. So the time is so important. Hard your study and try to unique and objective work. And I say good luck for your education life.
Thank you very much for your attention. If you have any question, just do not hesitate to email the professor, isn't it? Or using me, using the other lecture, you can contact the professor later on. Yes, yes. I think that's all for today for this session. Thank you very much. I ended this session. Assalamualaikum warahmatullahi wabarakatuh. Thank you. Take a photo first.